Still under capacitor, okay? This is my WhatsApp number in case if you need any assistance, okay? You need any assistance, just send me a DM, sharp, no time, Jamb, don't tune in, okay? So, energy of a capacitor using charge and volts. Energy of a capacitor using charge and volts, all right? So, let's look at the question we have in our midst here, okay? Jamb must repeat question 6. A capacitor stores a charge of 4.0 times 10 raised to the power minus 4 coulomb when connected to 200 volt supply. Calculate the energy in the capacitor. Very easy. All options represented in joule. That's the SI unit of what? Energy. Okay, they said we should calculate what? The energy. Energy, which is E, is equal to question mark. Now we define. Okay, this question, you see, this question is not supposed to take you reach 15 seconds to solve. Very, very easy. All right, so let's now write out the formulas for energy of a capacitor. It has about, is it 3 or 4 formulas? Make I write the one where I can remember first. E, which is energy, is equal to 1 over 2, that's half CV squared. This is the most common. You also have another one again. E is equal to 1 over 2 QV. Yes. Then you have the final one. E is equal to, this one Jamb is set and well with Q square over, what should be C, 2C. Okay. So these are the 3 formulas for what? For energy of a capacitor. Okay. So how are you going to choose the right choice between 3 of these formulas? Depending on the parameters they give you in the question. Okay. Now let's write out what they gave to us to solve. All right. So a capacitor stores a charge of this. This one are the charge, and charge is Q. So Q is equal to 4 times 10 raised to power minus 4. I don't just care to put that 0 because I don't get space and you know to get use for it. Okay, it's represented in what? Coulomb. Okay, which means it is not going to need any conversion. Okay, charge is supposed to be measured in coulomb. When connected to 200 volt supply, so volts is our V equal to 200 V. Okay, no conversion still. Calculate the energy in the capacitor. All right, so energy question mark. Let's calculate. So we're giving this quantity of charge or charge and volts to solve. So which of this formula you think say go work well to solve? So the easiest formula to use to solve this thing to get the answer is this number 2. Because we get charge here, because we get volts. This one now, it gets capacitance, it get volts. We don't get capacitance, don't give us capacitance. Now the one we get charge and volts we go use, see and here. So applying this formula here, we are going to have E, let's put it at E, 1 over 2 QV. Alright, so since we are solving with this, we are going to what? We substitute into the formula. E now is equal to what? 1 over 2. What is our Q? Our Q is 4 times 10 raised to power, bracket, 4 times 10 raised to power minus 4 times V. What is V? 200. 200. Okay. So, I would like to convert this thing to normal form. Okay. Figure equal to 1 over 2. Convert this thing, we're going to get times 0.0004 times 200. If this one cancel this one cancel this one, we are going to be left with 0.04. E equal to 1 over 2 times 0.04. 0.04 times 2, where we get here, it will going to be about 0.0 something. Okay, times 1, we get the same thing. So it will now be E equal to 0. What are we going to get? It's not 0.08. 0.08 divided by 2, that should be 0.04. I'm not with my calculator, and this thing is just, they do me. So use your calculator to punch it. I don't they too like they use calculator to solve all these things. So use your calculator to punch it and drop the correct option. Drop the correct answer in the comments. All right. Drop the correct. I don't know if this is the correct answer because I'm not with the calculator. So I just use my head to solve it. But let's know if this is the correct answer. Drop it in the comment section. Transmission. Calculations under what? Power transmission. It's very easy. Trust me. It's very easy. This one are high yield for Jamb UTME questions. Now high yield. If you need any assistance, you need shortcuts to prepare for Jamb UTME, please connect with me on WhatsApp. This is my what? My WhatsApp number. Okay, connect with me. Let me give you shortcut maybe for pass. Okay, Jamb must repeat question 1. It reads, electricity is supplied to a school along a cable of total internal resistance 0.5. That's total internal resistance. They give us as waiting 0.5. That's R is equal to 0.5 ohms. With the maximum current drawn from the mains as 100 ampere. Then we will go right and say current. Our current, now waiting. Current is equal to what? I equal to 100 ampere. Okay. The maximum energy dissipated as heat for 1 hour is what? The maximum energy dissipated as heat for 1 hour is what? They give us time equal to 1 hour. Okay. Any other thing? They say we'll calculate with it. Maximum energy. Okay. Or can we say power loss? Okay. Maximum energy. Now they say we'll calculate. E is equal to question mark. They say we'll calculate the energy. Alright. So looking at what we have here, we have time represented in hour. And you know, say we don't use this hour stuff. So maybe we convert this time here. Okay. So to convert from hour to seconds, we are going to do 1 hour is equivalent to 3,600 seconds. That's it. It's 60 times 60. Okay, since 60 seconds make 1 minute and 60 minutes make 1 hour, is going to be 60 times 60. 60 times 60 equal to 3600 seconds. All right, so that's that for that. All right, 1 hour. All right, so let's now write out the formula to calculate energy. Okay, so we should calculate maximum energy. The formula is energy equal to power loss subscript loss. Okay, power loss times time. That's the formula for energy. Now let's compare if we can use this formula to solve it. Do we have energy here? That's what we are looking for. Power loss. They give us power loss. No. They give us time. Yes. Now only time they give us. We have power loss only. So we have to find this power loss. All right. So how do we find power loss? Now there the wahala come now. How do we find power loss? So we need to apply electricity formula to get power loss. Okay. Just add electricity power loss to electricity formula. Power loss P loss is equal to I square R. I square R. Okay. Power loss is equal to I squared R. But this formula will work. Yes, it's going to work. They gave us resistance. See, I'm here. They gave us, we need current. See the current here. Okay, and no be now we want use time. See where we will use time here. So this one will work. So when we substitute, power loss is equal to I square, 100 square, 100 square. Okay, times what is R? R is 0.5 ohms. So 100 square will give us waiting. That will give us equal to 10,000, sorry, 100 square, 100 times 100, it's not 10,000, times 0.5, that will give us what? That should give us about 0.5 times 10,000, about 5,000 or so, 5k, 5,000. What is SI unit of power? Watts. So the power loss is equal to 5,000 watts. P loss is equal to 5,000 watts. So since we now have P loss, we can apply this formula and get our answer. All right, the formula energy equal to what? P loss times time. Okay, we already have our time. Energy is equal to what's our P loss? 5,000. Okay, times what? Times time. What's our time? 3,600. Okay, 3,600 seconds. Look at it here. Okay, so when we times, what do we get? This times this will give us, it will give us 18 million. 18 million. So do we have 18 million among the options? Options, they standard form and in joule. Okay, so what are we going to do? We are going to convert this to standard form. What's it called? We are going to convert this to standard form, yes. So if you want to convert it to standard form and leave the answer in two significant figures, I already see answer will resemble one here. So now this answer will get last. So if you want to convert this thing to waiting to two significant figure, you can put points here. If you can start to count from here where you put points 1, 2, 3, 4, 5, 6, 7. That's raised to power 7. 1.8 times 10 raised to power 7 joules. All right. So E is equal to this. All right. So pick the correct option and drop it in the comment section so that I will understand that you understood this lecture. Question 2 reads, a transformer which can produce 8 volts from a 240 volts alternating current supply has efficiency of 80%. If the current in the secondary coil is 15 ampere, calculate the current in the primary coil. All options represented in what? In ampere. That's not current to define. Since we are talking about transformer here, the question is talking about transformer, and they mention secondary coil, constantly mention primary coil. That should tell you that you have to understand how transformer works. And I've already taught transformers. I taught you transformers already. So you should know that when we are talking about transformer, where does the current enters? What coil does the current enters before it enters the other coil? Which coil the current where they enter? Does it enter the primary coil first or the secondary coil? Where the they enter? Okay, where the they enter? So that's what you have to put into consideration to answer this question. Okay, you have to put that into consideration, because if you don't know that, solving this can be difficult for you. Okay, they said what we should do, what we should calculate the current in the primary coil. The formula we're supposed to apply for this current in the primary coil is just this formula P1, which is power 1, is equal to VP times I subscript P. So 1 is for primary. Okay, 1 is for primary current, primary volt. So this one is power in. Okay, power in, and this was gotten from, all these were gotten from the formula of efficiency. Okay, power efficiency. Let me quickly write out the formula. The formula is given by efficiency, power efficiency is equal to power out over power in times 100%. So this was the formula for efficiency. They gave us what? The efficiency, which is what? 80%. What else did they give us? They gave us what? Volts. Okay, they give us volts equal to 8 volts. Okay, what did they give us? 8 volts from a 240 AC supply. All right, produce 8 volts. This one is the volt that it produced. Okay, so this one is the volt of the secondary coil transformer, which can produce 8 volts from it produced 8 volts from this one. So this one should tell you that this is like, this one is the voltage, okay, that was, induced into the transformer, into the primary coil, okay. So it now stepped down the volt to this one, okay. So what part does this volt passes in the transformer to be stepped down to this? It should be the secondary coil. So this is not correct. This should be volt of secondary coil equal to 8 volts. All right. So this one will now be the general volt where they put inside the transformer. Okay. AC supply. Okay, AC supply. The efficiency is 80% if the current in the secondary coil is 15 amp. So current in the secondary coil, that's I secondary coil, is equal to 15 ampere. All right. Calculate the current in the primary coil. So current in the primary coil equal to unknown. Now be waiting we define. This thing is very easy. Okay, you just have to think. Okay, you have to think. We are looking for current in the primary coil. We also have to know the volts of the primary coil too. All right, because we want to use this efficiency formula, we have to find this power out. Power in is here. Look at the power in here. That's what they gave us here to solve. Power in, no power in. Okay, power out, no power out, efficiency. So we are looking for the power in. All right, so we want to use this efficiency to find the power in. That's what we have to do, because we want to apply this formula. Okay, so to calculate power out, we are going to do, let's look at the formula. This question is quite complex, but let's look at the formula first. I also say I solved this thing correctly. Equal to V secondary times I secondary. So V secondary times I secondary. Volt of secondary coil times what? Current of secondary coil. Do we have it here? Yes, we have current of secondary coil here. Volt of secondary coil. Yes, we still have. So let's do it. Power out is equal to, volt is 8 times, what is the current? 15. Okay, that will give us what? That will give us 8 times 15 will give us 120 watts since it's power. Okay, so now we get power out. We'll go apply this efficiency formula. More you're applying for here, more you're doing for here, I beg. Efficiency, they give us efficiency which is 80%. Okay, 80% now 0.8. If you do 80 over 100, you'll get 0.8. That's equal to, what is our power out? See here, power out 120 over what? What is power in? We don't get power in here. Okay, let's just put it power in like that. Okay, then since we have power in here, it's a letter, and we have the rest and number. The best thing is to cross multiply. If we cross multiply, we are going to have P1. This one will not be over 1. P1, this P1 times this. P1 0.8. Okay, that's P1 0.8. P1 0.8 equal to this one 120. Okay, so what are we going to do? We divide both sides by the coefficient of P1. All right, P1 0.8 equal to P1 0.8. Okay, this cancel this, we bring down our P1. 120 divided by 0.8, we are going to be left with 120 divided by 0.8, 150. P1 equal to 150 watts. Okay, 150 watts. All right, so we've gotten P1 now. We are now going to apply this now to find the current in the primary coil. This one signifies the current in the primary coil. Okay, so now let's apply this, okay, to find it. Do we have P1? Yes, this one are P1. Do we have VP? That's the volt. Okay, the volt. Yes, that's this one. Now this one be that. So what do we do here? We are now going to do P1. Our P1 is 150. We are using this formula. Our P1 is 150 equal to VP, which is 240 times P1. All right. What do we do here? We go just do this one, and you know what we're supposed to do now? We divide both sides by the coefficients. 240 times P1 will give us 240 P1. Okay, 150 equal to 240 P1. When we divide both sides by the coefficient of P1, 240 P1 over 240 P1. Okay, so if we do this, we are now going to be left with this, cancel this. We bring down our P1 is equal to 150 divided by 240. We are going to be left with 0.625 ampere. So among the option, do we have any fit for this? Do we have answer like the closest answer? So among the option, pick the closest option to 0.625. Okay, 0.625. Pick the closest option and drop it in the comment section.